Hello, everyone. Thank you for being here. Share my screen real quick and we'll get started. Okay. All right. Thank you again for being here. This talk is clean code with unit tests, tips and tricks for keeping your test suites clean. My name is Tyler Hawkins. I'm a senior software engineer and tech lead at Adobe. I've been working here for the past few years. I'm loving it. If you want to reach out to me at any point, you can find me on LinkedIn. You can find me on Twitter. You can find me on Medium. I love to write. So if you want to look at the things I'm writing about and thinking about, Medium or Dev is a great place to find me. Okay, so what we'll cover today, we're going to talk about the importance of writing tests briefly. We'll talk about the importance of writing clean tests. And then we'll look at 11 ways to make your test code cleaner. So that's what we'll go over today. So just as a brief kind of setting the stage, the importance of tests. Why do we write tests at all? There are a few big reasons. The first being that tests prevent regressions as you modify code. Code changes all the time. If you work on a large code base, you're working with many, many different developers, maybe hundreds or thousands of developers. And maybe that code base has existed for maybe a short amount of time. Maybe it's existed for decades. But as you modify that code, sometimes you'll break things. You might not have the full context. You might not fully understand the implications of changing a certain branch of logic or certain file. So tests are there to help prevent regressions. They'll let you know if something is wrong or breaking. Secondly, tests serve as documentation. When you write those tests, you're documenting the behavior as the app currently works, and you're documenting your expectations as a developer. It's a great place to clarify basically the product requirements and how this code should be working. And then finally, tests save you time by not doing tedious manual testing. If you're spending hours each day, or maybe your QA team is spending hours each day manually testing the app because you don't have automated tests, that's probably a waste of time. It's probably good to start getting those automated tests in place. So in short, tests enable change. They allow you to make changes more easily with more confidence and give you that peace of mind that you're not breaking things in your app. Looking at some words from Martin Fowler from his book, Refactoring. It's a great book. Highly recommend it if you haven't read it. He has this quote. He says, if you look at how most programmers spend their time, you'll find that writing code is actually quite a small fraction. Some time is spent figuring out what ought to be going on. Some time is spent designing, but most time is spent debugging. And as we write these tests, right, this is going to help us in our debugging efforts, help us in our in our efforts as we're reading and trying to understand this code. This is Uncle Bob, Robert Martin from Clean Code, another great book. He says, test code is just as important as production code. It is not a second-class citizen. It requires thought, design, and care. It must be kept as clean as production code. So this is an important concept here, is that we spend a lot of time making sure production code looks good. Hopefully we spend time refactoring our code and making it easy to understand, easy to work with. But sometimes we don't give that same amount of thought to test code. We let our test code get a little bit dirtier. And Uncle Bob here is reminding us it's not a second-class citizen. It's just as important. As he goes throughout this chapter, he kind of makes a slightly less bold statement. A few pages later, he says, the code within the testing API does have a different set of engineering standards than production code. It must be simple, succinct, and expressive, but it need not be as efficient as production code. After all, it runs in a test environment, not a production environment. And those two environments have very different needs. So he kind of walks it back a little bit. He says, okay, test code is important. It's not a second-class citizen, but there is kind of a different set of standards for test code versus production code. And then even just a few pages later in his book, he walks it back a little bit more. So now he says, there are things you might never do in a production environment that are perfectly fine in a test environment. Usually they involve issues of memory or CPU efficiency. but they never involve issues of cleanliness. So I think that's a pretty important distinction, right? Is that sometimes, yeah, maybe we don't write the most optimized code in our test. Maybe it's not as efficient as something we would do for production code. But when it comes to cleanliness, there's really no excuse to write code that is less clean in our test code. So as we think about these things, just kind of a working definition of what we mean when we say clean code. To me, clean code is code that's easy to read, it's easy to understand, and it's easy to change. So today we're going to be looking at how we can write our tests and our test suites so that they're easy to read, easy to understand, and easy to change. So with that, let's look at 11 ways to make your test code cleaner. All right, so the first one is structuring tests. When you structure your test in a predictable way, it's a lot easier for people to read and understand them. There's a very common pattern for structuring your test. It's called arrange, act, assert. This pattern has many different names. They all mean the same thing, but sometimes you'll hear it as build, operate, check, or setup, exercise, verify, or given, when, then. But they all have the same basic setup. And so in those three phases of the test, arrange, act, and assert, during the arrange phase, we set up our code, our components, our objects. We set up those test fixtures needed to run the test, right? Then we act. We do something. So we call a function. If you're writing tests for front-end code, maybe you click a button, but you exercise something on that code, right? So you've set it up in the arrange, and now you actually do something with it in act. And then in assert, you assert that the expected behavior happened. So you called a function with this input, and now you will assert that the behavior, you will assert that the output equals a certain value, right? So arrange, act, assert. If we want to look at that, so I primarily work as a front-end engineer. So this is some JavaScript testing some React code. If you're not a front-end engineer, don't get too hung up on that. All of these principles will still apply whether you're writing front-end or back-end code, and really regardless of what language you're using. But as an example for arrange, act, assert, you can see here we have a test that renders a button element with the children provided. And so on that first line, we render the toggle button. And so in that one, we've kind of combined arrange and act. We've arranged our test fixture with that component, and we've acted by rendering it. And then we make some assertions. So we expect that the text bold is available in the document in the UI, and we expect that there's a button element in the document. So we've made those assertions. Now, as you write a little bit more complicated tests, you might find that you are acting and asserting and acting and asserting multiple times, and that's perfectly okay. So you can see in this example, we have another React component test. So this test says it allows the user to toggle the button between pressed and unpressed states. So in this one, we do our arranging on those first 8 or 9 lines of code there. So we have created this component that we can toggle on and off of this toggle button state. And then we act, we render it, and then we assert. We assert that there's this text bold in the document, and we assert that it has this aria pressed attribute as false. Then we act again. We click on that button, and then we make an assertion. So we assert that now it has aria pressed true. And then we act again, we click on that button again, and we assert again. We make sure that aria pressed is false. And so as you write a test, it's okay to do multiple acts and asserts throughout your test. But what you want to watch out for is if you have if you find yourself doing the arrange phase again, that's probably a good sign that this should be a separate test. If you're now resetting up your test fixture or your thing that you're going to be acting upon and making assertions against, it's probably a good sign that this should be another test. So only do your arrange setup once. Okay, second thing, we can use test builders. So we can use test builders to create commonly needed objects. So this will very much be domain specific to the thing that you're working on. But for example, maybe you need to create a user object or a customer object. And maybe this setup for this user or customer takes a lot of code. And maybe it's kind of tedious to write that out every single time for each test. And it clutters up your test with all of this kind of setup code that you've created. So one solution to make that cleaner is to use these test builders. And so this is just an example, but in the JavaScript world, there's a cool NPM package called faker.js that helps you with these test builders. You don't have to use a third-party package. You could do this yourself, but this is just a useful package. And so in our example, we've created this build user function. And in this build user function, you can provide it these options. And you can see that down at the end, we spread those options. So we allow the user to override them, but we do set up these random default values. So we set a random UUID for the user ID. We set up a random first name, last name, job title, phone, email. And this just creates this user object for us. And so then further down, you can see the usage in the test file. We would just import that build user method. And then if we wanted to create a user with all the default values, we could simply just say user1 equals build user. And there we go. We've kind of abstracted all that code away into this helper function, and we can create a user very easily in one line. And then at the very last one, the user2, you can see if we do need to specify some overrides, we could do something like specifying the user ID as 100 and the email as test@test.com. In the event that we need non-random values. So these test builders really help kind of abstract away the test setup and make it a lot easier to create these test fixtures that you need. That way you can focus more on actually writing your tests. Okay, next tip. Let's look at, for every test, you should have just a single concept per test. So we touched on this a little bit with the arrange, act, and assert, but it's important that you don't try to test several things all in the same test. For example, maybe you have this test that says it renders in various states. That's very vague. It doesn't really tell you specifically what you're trying to test here. Maybe you've rendered, a specific component in very different differing states, and you're trying to test those all together. That's not a great test. As a good example, you could say it renders the date picker when the user clicks the text input. That's a very specific test. It's very specific in what you are actually testing, and we're only looking at a single text input, single concept. Okay, next one, tests should be fast. Slow tests are a pain to run. I don't know if you've ever worked with test suites that take an hour or more to run. Those are not fun, waiting for those to run and to get your test feedback. Sometimes when tests are really slow, they become optional. And when something becomes optional and it's slow, that just means that no one's going to run it. So slow tests can be painful. On the other hand, if you have your tests that are fast, fast tests can be run while you're writing production code. Ideally, you're running your tests alongside, maybe in a separate tab or something, you're writing your tests at the same time as you're writing your code. And so you can get that instant feedback, that very quick feedback loop, so you know when your tests are passing or you know when they're failing. So tests should be fast, help speed up that feedback loop. Next, tests should be independent. Tests should be able to run in any order, and any given test should not depend on the test before it. I don't know if any of you have ever had a kind of testing, debugging headache in the past where when you run all your tests, certain of them fail, but then when you run the test individually, each individual test pass, and you're left kind of shaking your head of, why do these all fail when I'm running them together, but they pass when they're individually? And usually the reason for that is there's some sort of interdependence between the tests, where maybe one test modifies this piece of shared state or this global object that the next test uses. And because of that, they've now become interdependent, and the order actually matters, which is not great, because if the order matters, that means you can't run these tests in parallel. They always need to be run sequentially. So the takeaway here is to remember to do any cleanup or teardown needed. Just about all test frameworks have like these before each or after each, or these setup or teardown kind of hooks that get run before or after each test. So remember to do that kind of cleanup so that you don't have interdependent tests. Next, tests should be repeatable. So tests should be able to run in any environment. If it passes on my machine, it should pass on yours. When you have tests that are flaky, it lowers your confidence in those tests. They pass sometimes and then they don't pass other times. You never really know, is something actually broken? Did I change something and I did something wrong? Or if I just rerun the test, is it going to pass? That leads to a lot of frustration for developers. So make sure that they're repeatable, that they're consistent, they're not flaky. Next, tests should be self-validating. So we kind of take this for granted in our test frameworks today, but in just about every test framework, when you run a test, it returns a Boolean. It passes or it fails. Back in the day, you might not have had that kind of functionality. You might have, written a test and it makes an assertion and then prints out the output, and then it's up for the human to interpret the results of the test, which isn't great, because you shouldn't need a human to interpret the results of the test. The machine should be able to tell you this passed or this failed. And this is partly why things like snapshot tests are not great in the front end world, particularly with using Jest. You have the ability to take what are called snapshots, which are basically just an XML representation of the DOM. And when you run the snapshot test, it gets saved in the snap file. And then when you run that test again, if something has changed, the snapshot test will tell you, hey, something has changed. But then you as the human have to go interpret that. And you either have to decide, yes, that change is expected, or no, that change is not expected. It's a lot better when your test can just tell you this passed or this failed. It should be self-validating. Okay. Next, tests should be written in a timely manner. Tests should be written at the same time as the production code, not months later when trying to play catch up. TDD, test-driven development, is a great development paradigm in which you write your test first and then you write your code to make the test pass next. Even if you're not a big fan of TDD, writing those tests shortly after writing your production code, so basically in your same merge request or pull request, is a great practice. As you're writing those tests, you are the one with the most domain knowledge at that time. You know what your code is supposed to be doing. You're probably the most qualified person to write that test and to make assertions for what you think your code is supposed to do. It's much harder when maybe you've inherited a code base that doesn't have very many tests, and now you're trying to write tests to increase your code coverage and get a little bit more, a little better of a test suite in place. It's a lot harder. You don't have that same domain knowledge. Even if you did write the code 6 months ago, maybe you've forgotten and you don't quite know what this is supposed to be doing. It's much harder to write your tests when you're writing them later. So tests should be written in a timely manner. All right, the next one. Make sure tests fail when they should. Another rhetorical question, food for thought, but have you ever come across a test that doesn't test what it says it does? It's maybe passing and it says it's testing one thing, but really it's testing nothing at all, or maybe it's testing something completely different. This creates this false sense of confidence. And so one piece of advice that Martin Fowler has for us, this is again from his book, Refactoring. He says, I like to see a test fail at least once when I write it. And so what he means by that is maybe you write a test and it's passing. Maybe you go change your assertion where instead of this function should return 10, go change your assertion to say this function should return 9. and make sure that that fails, that it tells you, no, it's not 9, it's 10. And then go put your test back in place, right? Don't commit that failing test that you'd written that was wrong. But it's good to get like a quick sanity check to make sure that your test is actually doing what it says it should do. All right, next tip. Remember to test your edge cases. So we can look at this example problem. What test would you write for this example problem? So if we had this problem that said, write a function to return the type of a triangle based on the value of the length of 3 sides of a triangle, how would you write that? And how would you write tests for that? You can see down below, we have kind of this pseudo code of how you might write this. So this is, again, the actual like production code, not the test yet. But maybe you would write a function called triangle type, and it takes 3 arguments for side 1, side 2, and side 3. And then you say, if all 3 sides are equal, then it's an equilateral triangle. Or if 2 sides are equal, so side 1 and side 2, or side 1 and side 3, or side 2 and side 3, then it's an isosceles triangle. Otherwise, if they're all different, it's a scalene triangle. So that's maybe a simplified version of the code that we might write for this function. And so if we were to think about what tests would we write for this example problem, some that might come to mind is maybe you would write these 3 tests. Maybe you would write one for triangle type 4, 4, 4, and you would make an assertion that running the function with those arguments returns equilateral triangle. As a second test, you might write, let's assert that triangle type 6, 7, 6 returns isosceles triangle because the first and third sides are equal, but the second is not. And then third, you might write a test for 6, 7, 8 and assert that that's a scalene triangle, that all 3 sides are different lengths. And as a developer, you might call that good. You might say, okay, I've tested my function and I validated those 3 sides, those 3 types of triangles, and this is looking good. And as the code currently stands, you'd have 100% code coverage, saying that you've covered every line of code. But let's think about our edge cases here for a minute. What other kind of tests could we write? We've got 3 more that we've added. What if you had the arguments provided of 0, 0, 0? That's not a triangle, that's a point. If each of the sides have 0 length, that's not a triangle, so that's an edge case. What if you provided negative values? What if you did -6, -7, -8? That's not a triangle because triangles can't have negative lengths. And then even a more fun one, what if you provided the values 5, 3, and 8? Those are all positive numbers, but if you were to try to construct that triangle, what you'd end up with is actually a line. Those lengths aren't different enough, right? Where it would kind of just fold in on itself and create a line. And so the takeaway here is just to remember to test your edge cases. A lot of times we fall into the trap of testing just the happy path of, okay, I have this basic requirement and here I go, I wrote the code and I wrote the test for that. But think about the edge cases, think about what could go wrong, think about invalid input and how you might handle those. All right, the next tip, test the things you're most worried about going wrong. So this is more of a personal philosophy, but I strongly believe that we should shoot for 100% test coverage. People will argue all day about, what's good enough, right? Is it 60% or 70 or 80 or 90? But let's shoot for 100. If you're not going to test something, you should have a pretty good reason why you're not going to test it. But that being said, there is a law of diminishing returns. Maybe you're at 99% test coverage, and that last 1% is just really, really hard to get to. And it's maybe not worth your time. Maybe it's not something worth testing. So make sure to follow that 80-20 rule, that Pareto principle. Just understand that not everything is worth testing. So shoot for 100% test coverage, get as close as you can. But if you're very close and don't feel like you can get that last 100%, don't stress too much about it. Okay. That is the end of this presentation. So just in summary, unit testing tips and tricks, structure your tests using arraign, act, assert. That will make your test much easier to read and to reason about. Use test builders to make test setup easy for commonly used objects. That's going to reduce the amount of code that you need to write and will help you focus on the actual assertions you're making throughout your tests. Evaluate a single concept per test. Make sure you're just testing one thing at a time as opposed to trying to test multiple things in a single test. You can remember the acronym FIRST. Tests should be fast, independent, repeatable, self-validating, and timely. Next, make sure tests fail when they should. Make sure you're not getting those false positives. Remember your boundaries and edge cases. So again, when we looked at that triangle exercise, don't just think about the happy path. Think about these boundaries and edge cases. Think about what could go wrong. And then lastly, test the things you're most worried about going wrong. Make sure you have those important tests in place. And don't stress so much if there are some things that are not as important that you're not able to test. Thank you. That is it. Again, if you want to get a hold of me, my name is Tyler. You can find me on LinkedIn, Twitter, Medium. With that, I'm going to stop sharing my screen and we'll do some Q&A. I see that there are a couple questions in there right now. So let's grab those. Just 1 second here. All right. So we have a few questions. Give me 1 second to look at this. Okay, it says, quick question. If we have made mistakes and we rolled out a project that is not easy to read, easy to understand and change, should we go back and reformat the whole thing? Let's say that the application already has multiple users. Yeah, that's a great question. So should we go back and reformat the whole thing? That's always a fun question because basically I think kind of the crux of the question, what you're asking here is, should we scrap the whole project and rewrite it? Or should we incrementally try to improve it? And usually the right answer is to try to incrementally improve it. When people try to do a rewrite, oftentimes what happens is they are trying to rewrite or completely rewrite the code base while the original code base is still being used and it's still being changed. And now they're trying to keep those two in sync. And then they realize that there's a reason for all these different edge cases that the spaghetti legacy code has made. And by the time you're done with the rewrite, you've basically created the same thing in the legacy code. So rewrites are often difficult and expensive and can take years. So I'd highly recommend making these incremental improvements. So if you've already rolled out this project that, yeah, maybe isn't super clean, take time to refactor it as you go. All of these principles, I've mentioned a few of these books sometimes already of clean code and refactoring. The Pragmatic Programmer is also an excellent one. Those 3 books have excellent tips on how you can refactor your code as you go. So I'd highly recommend just kind of following that Boy Scout rule. Leave your code base better than how it was when you found it. So with each new merge request, maybe you refactor your code a little bit more. Maybe you clean up this messy method. Maybe you find something you need to refactor with each one. So I'd say do it slowly over time rather than trying to do that rewrite. Okay, And now we have a second question. This one says, why do we override a user instead of creating an instance? Yeah, so this is talking about the test builders, the test builder functions that we looked at, where we set up this function that we could build a new user. So maybe that part wasn't super clear, is that we're not necessarily overriding a user. With each time that you use this test builder function, you are creating a new user. So it is a new instance of that user. But what we're doing there is allowing you to provide overrides for those default values. And so what we saw there was those were just arguments that you could pass in this options object to a function. If you wanted to turn this into like truly object-oriented thing, maybe we would turn that into a class. And then you have a constructor where those are the defaults, but then you can provide additional values in the constructor as you initialize the class. But the concept is the same, is we create a new user object. And when we do so, we can either just stick with all the defaults by not providing additional arguments, or we can override some of those defaults by providing additional arguments. There you go. Hopefully that helps answer that question. With that, those are all the questions in the Q&A. So I think we're all set. So thank you so much for being here. I appreciate your time. Again, you can go find me on LinkedIn or Twitter or Medium. And I hope you have a great rest of your day. Thank you.